A very good evening to all of you. Today we have discussed a very important topic of the building materials for the competitive exams. That is the cement. So, as we all know that the cement is one of the most important building material, and it is a fine powder that act as a binder when mixed with the water, aggregates, and other materials to forming a hard and a durable substance. Cement is a key ingredient of the mortar and concrete. So basically, it is used in the construction for the structures like bridges, roads, foundations, and so on. And the most common type of the cement that is used in is the ordinary Portland cement, that is OPC. So as we all know, the Joseph Aspidin was the first one to introduce the Portland cement in 1824, formed by heating a mixture of limestone and finely divided clay in the furnace to the temperature. So this is very important for the competitive exams. Who is the founder of this ordinary Portland cement? So that is the Joseph Aspidin, right? Next, the cement is divided into the two categories. First one, that is the argillaceous compounds. It is basically based on the clay, and the calcareous compounds, that is the lime-based compounds. So by mixing these two compounds, then forms the a hard and a durable substance. So basically these are the different types of the constituents of the cement. This is very important in terms of the competitive exams. Like the highest percentage of the constituent of the cement is lime. It consists of 62 to 65%. Silica, that is 17 to 25%. Alumina, Al2O3, that is 3 to 8%. Gypsum, 3 to 4%. Iron oxide, Fe2O3, 3 to 4%. Magnesia, that is 1 to 3%. Sulfur, 1 to 3%. And alkalis are very less, so you can say the percentage is 0.2 to 1. So major constituents of the cement is lime, silica, and alumina. And lime and silica, that is basically responsible for the strength. So now the functions of the different constituents of the cement. So first, as we all know that the maximum percentage of the constituent of the cement is lime, which having a percentage of 62 to 65%. So basically it imparts the strength and soundness. So soundness, you can say that soundness means the resistance towards the change in volume. So basically lime is responsible for the soundness. So if it is in axis, so it makes the cement unsound and cause it to expand, disintegrate. And if this percentage is less, then it reduces the strength of the cement and cause it to set quickly. Now next is the silica, that is also the percentage of the silica is 17 to 25%. The percentage value is very important in terms of the competitive exams, because these are asked in many JE exams. So basically it imparts the strength of the cement, and if it is in excess quantity, then increases the strength of the cement as well as also increases the setting time of the cement. Third constituent, that is the alumina. Basically this is responsible for the plasticity. So it imparts quick setting property, and if it is reduces the clinkering temperature, if it is in excess, weaken the cement. Next is the gypsum. So it consists of 3 to 4%. It present in the form of calcium sulfate, CaSO4. So it is basically used to increase the initial setting time of the cement. Next is the iron oxide, that percentage is 3 to 4%. It imparts the color, basically the reddish brown tint color, responsible for the presence of iron oxide. Next is the magnesia, that it consists of 1 to 3%. It also imparts the color, but the color that is of yellowish tint. So you can say that the iron oxide is responsible for the color, and the color is reddish brown tint color. And the magnesia, that is also responsible for the color, but it is yellowish tint. And if it is in excess quantity, that makes the cement unsound. Now next is the sulfur, that is also the percentage of this constituent is very less. So it is responsible for imparting the soundness. The soundness due to the lime, magnesia, and sulfur. There are three constituents that is responsible for the soundness is the lime, magnesia, and sulfur. So lime and magnesia, the soundness due to the lime and magnesia can be measured directly, but there is no any test is available for the soundness test due to the sulfur. Now next constituent is the alkalis, which is found in a very less quantity, 0.2 to 1%. So basically it causes the efflorescence. Efflorescence means that is the white patches which is you have seen on the walls. So basically the presence of alkali causes the efflorescence and staining of the structures. Alkali, when react with the water, it may causes the white gray spots are formed. That is the process, this whole process, that you can say that the efflorescence. So alkali accelerate the setting time of the cement, right? Next, some important questions that is related to the different constituents of the cement is, so first important question is, which compound of the cement is responsible for the strength of the cement? So basically for the strength, there are the two constituent is responsible, lime and silica. Lime is in maximum percentage and the silica is a very less. Silica is below the lime. So in this question the lime is not shown and silica is shown, then the correct answer you can take is silica, right? But lime and silica both are responsible for the strength of the cement. So this is the answer. And if the quantity of the silica is in excess, increases strength of the cement but also increases the setting time of the cement. So this question that is asked in 2000 ESC Engineering Services exam 2014. Next question that is for the some general knowledge about the cement. So one bag of the cement, as you all know that the 50 kg, one bag of Portland cement that is of 50 kg and having a bulk volume of 35 liter is the correct answer. That is also asked in the ESC 2015. Now next is what is the specific gravity of the ordinary Portland cement? So in this question, so 3.15, that is the specific gravity of the ordinary Portland cement as per the IS code, this one. And it is also asked in